Evet, görünüyor hocam.
Tamam. Evet arkadaşlar. So let's start with the syllabus first. This is a course. The code is CSE351 Signals and Systems, and we offer this course in spring terms. So the class lecture is going to be on Wednesday from 2:30 to 4:30 p.m. and Thursday from 4:30 to 5:30 p.m. And it's going to be online over the Microsoft Teams. Genelde arkadaşlar bu dersi yani çok matematik yoğun bir ders olduğu için 3 saat blok yapabilirsek daha uygun oluyor. Tabii ki tüm arkadaşlara uygunsa yani 2,5'tan 5,5'a kadar yapabilir miyiz? Herkes için uygun mu değil mi?
Hocam seçmeli derslerimiz oluyor o saatte. Yani bugün bile çakışıyor aslında.
Öyle mi?
Hocam
Evet.
3.30'da lojik var bir de. Onu da çekeceğim
Lojik
normalde.
dersim var.
Aynen.
Nasıl alıyorsunuz? Lojik hangi kodu kaçtı onun?
Yok hocam lineer bu dersin şartı. Lojik değil.
Aynen.
Algebra.
Lojik 231. Yanlış hatırlamıyorum.
Bu arada arkadaşlar bu ders aranızdan 2. sınıftan alanlar var. O arkadaşlar mı? O arkadaşların durumu mu o şekilde? Yani normalde 2. sınıftan şu ana kadar hiç vermedik bu dersi. Bazı arkadaşlarımız 2. sınıftan üstten alıyor seçmeli olarak, ama bu ders seçmeli değil arkadaşlar. Bu ders mecburi bir ders. Dolayısıyla seçmeli alacaksanız teknik olmayan seçmelileri eklemenizi tavsiye ediyoruz. Kaç kişi 2. sınıftan alıyor? Üçüncü sınıf seçmeliyle çalışıyor diyor hocam.
Hocam Perşembe günü aslında bayağı bir müsaitlik var 3. sınıfta en azından. Saat 1.30'dan 5.30'a kadar yani müsait.
Ona mı çekelim diyoruz arkadaşlar?
Yok benim için uygun değil hocam.
Yok
Seçmeli
yok
dersim
yok.
var o
Hiç
saatte.
uygun değil.
Tamam. Peki çarşamba saat 11.30 12.30 arası.
Uygun değil hocam. Cuma gününe çekilebilir belki diğer arkadaşlarım.
Sesiniz gelmiyor.
Hocam açıkçası benim için bir tek bugün uygun gibi. Bu saat uygun gibi.
Çarşamba 11.30
Evet.
12.30 arası.
Ya o ya cuma günü. Onun dışında bence hocam çok fazla çekmeyelim.
Çarşamba dolu
Yok
hocam.
hocam.
O saatte
Ee,
ders var.
Data structures var.
Hocam benim datayla çakışıyor. Aynen datayla çakışıyor.
11.30'da datayla mı çakışıyor?
Aynen hocam.
Bir de
Data-
3. sınıftan hocam probability ile çakışıyor.
Tamam. Tamam, bu şekilde devam edelim. Bakalım nasıl olacak. Okay. So
Hocam özür dilerim. 12.30'da genelde tamamı boş gibi ama yani 12.30-1.30 arası.
ama öğlene rastgele uygun mu arkadaşlar sizin açınızdan?
Hocam çarşamba 12.30'a ders konulamıyor demişti bir hocamız ama emin değilim.
Ya bu gayri resmi olacak şekilde yani 1.30'da yani 3 saat üst üste yapabilmek için.
Hocam operating sistem dersimiz 11.30'dan 1.30'a kadar koymuşlar.
Tamam, o zaman her türlü çakışma var.
Yok hani şey diyorum hocam yani konulabiliyor.
Başka gün hocam o.
12.30 hocam iyi gibi sanırım. İtirazı olan var mı acaba?
Kaç?
O 12.30-1.30 arası öğle tatili gibi gözüküyor ya, o uygun yani o saatler. Bilmiyorum ama
Aslında çok da uygun değil. Peş peşe neredeyse 5 saat ders görmüş olacağız. Yani ben verimli geçebileceğini düşünmüyorum o kadar blok ders.
5 oluyor. Evet hocam öyle bir problem var.
Anladım. 1,5-2,5 peki dolu mu?
Uygun gibi.
Evet, Usame de öyle demiş. Wednesday 13.30 16.30 arası arkadaşlar.
Herkes uygun gibi hocam bence.
Evet hocam öyle gözüküyor.
Perşembe
Uygun mu?
günü boş gözüküyor hocam.
Tamam.
Hocam çarşamba günü saat 3.30-5.30 arası lojik dersi var ama
O her halükarda zaten şey oluyor, çakışıyor. Sizin açınızdan da iyi olur. Yani bazen 2 saat falan 2 saatte üst üste şey yaparsam yani bir 10 dakika arayla ona da yetiştirebilirim size açıkçası.
Yine hocam çarşamba günü seçmeli ders var. Engineering Applications diye. Ama çok problem olacağını düşünmüyorum.
Hangi saatte?
3.30-5.30.
Yani zaten bu ders normalde 2,5-4,5 arası orada yapacağımız bir şey yok. Yani sadece bir
Evet
saat
doğru.
eklemeye çalışıyoruz blok şeklinde yapabilmek için. 1,5 16,5 arası 13.30 16.30 uygun mu herkesine?
Hangi gün hocam?
Çarşamba. Bir saat erkenden başlayacağız.
Uygun hocam.
Uygun hocam.
Evet,
Hocam isterseniz Teams'te ana sayfada bir şey nasıl desem anket tarzı bir şey oluşturalım. En
Tamam.
çok oy alan seçilir.
Yani çok değil de yani herkese uygun olan bir kişi şey olsa bile bu şekilde devam ederiz.
peki hocam perşembe günkü dersi aktaramaz mıyız çarşambayı?
İşte onu diyorum. Yani
Evet
işte
hocam perşembe günü
Yok onu lütfen
12.30'dan
almayın.
sonra boş sanki.
Yok perşembe.
Hocam çakışma her türlü olur. Yani anket daha mantıklı bence. Ya da siz bu saatte olacak dersiniz biter bence.
13.30 16.30'a çoğu uygun diyor. Bilmiyorum şu an herhangi bir şey olumsuz bir şey gözükmüyor.
Hocam böyle derslere yarım saat, bir saat o blok dersi, 3 saatlik derse geç katılsak sıkıntı olmazsa herkes uyuyabilir belki o zaman.
Yani anladım.
Hem kayıt alınıp
Neyse Cuma ve Pazartesi'ye de bakayım ben isterseniz.
Pazartesi çok iyi bence hocam.
Pazartesi.
Hocam pazartesi olmasa olur mu? Çünkü ders programına göre işte çalışan kişiler de var. Ona göre ayarladık her şeyimizi de.
Yani,
Hocam çarşamba için uygun olmayan diyen yok neredeyse.
Evet, çarşamba
Evet,
çok daha
çarşamba
uygun
güzel
olur
gözüküyor.
aslında.
yani çarşamba
saat
sadece
değil.
bir saat ekliyoruz. 1,5
Evet.
2,5 ekliyoruz.
Evet, pazartesiden ziyade çarşambaya yapsak daha uygun olur sanki
Tamam,
ama
o şekilde soruyorum. Herkes için uygunsa o şekilde, yoksa 2+1 devam edeceğiz. Yapacak bir şey yok.
Perşembe uygun hocam bence herkese.
Uygun
Ben
hocam
şuraya yazdım. Siz oraya cevap yazın basit olarak. Yani özellikle uygun olmayanlar yazsa daha uygun olur. Eğer varsa tabii ki.
Peki hocam dersten bir saat kadar erken çıkma gibi bir imkanımız olur mu çarşamba günü öyle olursa?
Olur yani, çünkü bunlar kaydediliyor. Geçen seneden de kayıtlar var. Yani aynı şeyleri anlatıyorum açıkçası. Yani çıkmanız gerekiyorsa başka ders için olur.
Peki hocam teşekkürler.
Şöyle
Çünkü orada
bir
çakışma var. 15.30'da başka bir ders mi var bazı arkadaşlarım?
Lojik dersim var hocam.
Tamam. Yani çakışma varsa tercih senin.
hocam 12.30-3.30 arası yapmamız mümkün değil mi? Yani o zaman doğru ard arda oluyor ama hiçbir derste çakışmamış oluyor böylece.
Öyle mi oluyor?
Evet
Evet.
o da makul gözüküyor.
Evet hocam.
Tamam, makul o arkadaşlar.
hocam çok ağır olabilir o zaman. Yani birimi
Ama
azaltmış oluruz bence.
İşte çakışmamış olur. Diğer türlü diğer derslerden girmiş olacak bazı insanların.
Evet yani hocam onu 12'den yap.
Bir saat erken başlarsak kimseye de sıkıntı olmuyor. Hani olan da zaten normal zamanda çakışan arkadaşlar. O yüzden bugün bir saat erken başlamak bence en mantıklısı.
Evet arkadaşlar,
Bence
son
de.
olarak diyorum ki Wednesday 13.30 16.30 uygun mu değil mi?
Yani hocam bir oylama yapalım en kötü yani. Herhalde.
Bence uygun hocam.
Oylama değil. Bir kişi
Uygun
bile
yap.
itiraz
Bize
etse yapmayacağım. Oy birliği gerekiyor. Oy çokluğu değil. Sadece uygun olmayanlar yazsın. Anlaşıldı mı? Sadece uygun olmayanlar yazsın. Tamam arkadaşlar, burada bitti. Tek bir seçeneğimiz var. 13.30, 16.30. Yok, 12.30 zor. Öğlen arasına rast geliyor. Tamam arkadaşlar. Bu şekilde saat işini hallettik. Eğer o saat uygunsa, uygun değilse 2+1 devam ediyoruz. Okey. Beni duyuyor musunuz arkadaşlar?
Evet, duyuyoruz.
Saat değiştirdik mi şimdi hocam? Kesin hani.
Değişmedi. Daha haftaya netleşecek.
Tamam.
Okay, so let's continue. My name is Hasari Çelebi. This is my email address. And my office is this. And office hours is gonna be, but in this case, I need to change. So it's from 1:30 to 2:30 p.m. And the instructor information, the course materials and announcement will be posted on the Moodle as well as the Microsoft Teams. So let's describe this course briefly. The main objective of this course is to teach the mathematical background of the signals and systems, which is the main underlying technology for many of the engineering, such as communications, seismology, speech, image processing, defense, consumer, even the economy, and so on. So this is one of the fundamental course in the science. So we're gonna teach you the main principles of the analog and digital signal processing at the introductory level, and then we will provide you some examples to learn these fundamentals. And the undergrad third year level course, the credit is 3. The class hour is 3 hours lectures. There's no lab. The textbook that we follow is from Lati. The title is Linear Systems and Signals. And about the grading information, the homework is going to be 30%, which you guys are going to have 3 homeworks throughout the semester. And the midterm exam is going to be 30%. And finally, the final exam is going to consist of 40% of your total grade. So all the exams are closed note and closed books. Normally, we will follow up this catalog, but if the situation is bad in the class, so we may use the bell curve. So depending on the situation of the class. My TA is gonna be Başak Buluz Hoca. You can guys contact her if you have any question. And then let's look at the tentative course schedule, what we're gonna learn weekly basis in this course. So this week is the first week. We're gonna start with the introduction today. And then next week, we're gonna move on to the signals and systems. What are the signals? What are the systems? And we're gonna define and describe these different types of signals as well as the different types of systems. In the third week, we start with the basic of the analysis tool, which we call time domain analysis of continuous time systems, because we have different type of systems. So we consider continuous time as well as the discrete time systems. And we only consider the linear system. In this case, we are not going to consider or learn anything about nonlinear systems in this course. So nonlinear systems is out of scope of this course. In the 4th week, so we will continue with the time domain analysis of discrete time systems. So we are going to use the similar approach, but this time we're going to analyze the discrete time systems. In the 5th week, we move to the Z transform and its properties. And the 6th week is going to be Laplace transform and its properties. And the 7th week, after all this, so we are going to learn the Fourier series. And in the 8th week, we're going to have a midterm exam during the class hour. After the midterm exam, we're going to continue the Fourier transform, which is different than Fourier series. So we will learn the Fourier transform and inverse Fourier transform and its properties, as well as some applications. And then after completing the Fourier transform, we are going to learn the sampling theory. So what are the main steps of a sampling theory, like a Nyquist and so on. After learning this sampling theory, we're going to continue with the Fourier transform, but with the different versions. So the first one is going to relearn the discrete Fourier transform, which we call DFT. And then the more practical version of this DFT is called FFT, which stands for fast Fourier transform. And then in the 13th week, we're going to have these another version of the Fourier transform, which is discrete time Fourier transform. And finally, we're going to review and complete the semester. So this is the tentative course schedule. If any change happen, I'll let you know ahead of time and update this table. You know all this, so cheating and missed exams, what you need to do. I don't expect you guys to cheat, so that's why I'm skipping this part. And the missed exam, if all the exams are mandatory, if you don't attend, you'll get 0. But if you're sick or have some excuse, so you need to request for the makeup exams. You know how to do it. So if you have any kind of excuse, you need to submit to the dean's office. And then if they approve, then we will have a makeup exam for you guys. Schedule, as I mentioned, some variation may happen about the topic. So if some change happen, I'll let you know ahead of time. So homeworks are due to the beginning of the class, and we don't accept any late homeworks. And midterm exam information is going to be in the 8th week in the class. Final exam, I guess they have announced or not, but we provided this information to the department, so they will announce as soon as possible. Okay, that's the. Yes, go ahead.
What do you mean by in the class for midterm?
At the, class hour, basically. Wednesday from 2:30 to 4:30. Oh, is that gonna
it's still online, right?
Well, it depends on the, this COVID situation. So initially they ask us to do face-to-face in the class, but we don't know yet. So it's too early to say whether it's going to be face-to-face or online. Okay.
Sir, a question. Do you mean by the due to the beginning of the class that the due time is will be Wednesday on
2:30?
2:30. Okay.
Yeah.
Got it.
All right. Okay, that's the syllabus. Any question about the syllabus?
I have a question, sir. If we have the exams online, what is the format going to be? Like, is it with the camera turned on, or how is it going to be?
So your camera is gonna be on. We divide into the groups, and there are TAs that watch you guys. And so it's like face to face. So the only difference is gonna be your camera is gonna be on. Okay.
Okay, thank you.
All right. Any other question? Is the syllabus clear? All right. So I already posted this on the MS Teams, so you can reach and download this syllabus from the MS Teams. Okay.
Sir, what is your standpoint on attendance? Is it mandatory or?
No, I don't follow you guys. So you're grown up guys. So even though it's a mandatory course, but it's up to you guys.
So like as we said, we have a lesson after this. Like it's on the second hour of this course. So if we exit 1 hour earlier, it's not a problem, right?
It's not. It's up to you. Yeah.
Thank you.
All right. Any other question? Okay, so since this is the first week, and because of the registration and so on is going on, so we're gonna have a first course today. Tomorrow we're not gonna have any course, but we're gonna start next week. Okay.
So is this week considered the first week, the introduction week, or is this week not counted? The next week will be the introduction.
No, this is the first week introduction that I'm gonna now move on to the first lecture, which is gonna be on introduction. But tomorrow we have 1 hour, so we're not gonna have that course tomorrow, just for this week.
I see. I got it. Thank you.
Okay. All right. So if you are clear, then let's move on to the lecture. The first one is introduction. Let me share you the slides. Can you see it, guys?
Yes.
Yes.
All right. Okay, so this is one of the fundamental course in the science in many disciplines, not only engineering, as well as economy or many things, so that we're gonna learn. So the outline for today was syllabus, to go over the syllabus, which we already have done. And then now we start to introduce some main concepts and about the scope of this course, what are the application, what are the main issues, and so on. So we will do some introduction to the signals and systems, including what is the signal, what is a system, and some examples in our daily life. Okay, the first question is, so the course name is Signals and Systems. So what is the signal? Any idea?
It's a transition of an information from point A to point B.
That's the transition, that's the communication part, right? What is signal?
Is it a medium that you use for communication?
Yeah, that's a called channel, right? What I'm asking is, what is signal?
It's a form of data being transmitted.
You don't have to transmit. You can just store it, save it, keep it, or receive it.
It's an electrical pulse, maybe.
Okay. Kind of. What else? Who else? Any other idea? Okay.
It's an encrypted message, maybe.
Encryption is just one process that we apply, but there's none encrypted many signals, you know. Most of the signals are not encrypted even.
Maybe it's a series of electrical pulses that correspond to some type of information.
Yes. So that's closest one actually. So mathematically, signals are functions of independent variables that carry information. So the signals, basically they carry information. But in terms of math, it's a function of different independent variables. We have different variables, you know, you can carry this information over the time, over the frequency, over the space, and so on. So simply, the definition of signals are the functions of independent variables that carry some information. And this information vary, can be speech, can be music, can be data, can be images, can be video, you know, different types of information can be carried out. And more specifically, like in economy, you have the stock, you know, exchange, which each company have some stock prices. So they keep change rate in like Borsa Istanbul, like BIST or NASDAQ in US and so on. So all these are signals, is a continuous time signals that, you know, this signal keep change, but it carries some information like US dollar versus Turkish lira, right? You know, keep changing. It carries some information. Another example is the voltage and current in a circuit. If you are from electronic engineering, so you develop or design a circuit can carry voltage or current signals, right? Or in terms of weather, the temperature in a city like in Istanbul or in Gebze is keep changing. So this signal basically carry the temperature information. Or there are some other signals, medical signals, that carry the gene sequence or DNA sequence information. So there are some, you know, signals that carry the pressure. Some of them, they carry the vibration and so on. You can extend this list, you know, but, you know, signals is everywhere basically. In an economy, in medicine, in engineering, in telecom, and so on. Okay, so in the definition, there's a word called independent variables. So it's a function of independent variable. What are these independent variable? We're gonna learn. Before that, we basically split the signals into two parts. The first one is continuous time. The second one is discrete time that we're gonna learn next week in detail. When we say some example for the continuous time signal is analog audio signal or position of a trajectory of a robot that we have, or a temperature distribution in a room, all these signals are some examples for the continuous time signals. In terms of discrete time signals, some examples can be digital audio signal or DNA sequence or the some image pixels. So in mathematically, the independent variable can be multiple, one or two or multiple independent variables, such as time, frequency, and space. But in this course, we only consider the signals with one independent variable, which is the time. So we don't consider, or we're gonna learn the other multiple variables signals, such as the space or frequency. We only deal with one variable at a time. Of course, we're gonna, all the signals in daily life is a function of time basically. But when we analyze this kind of signal, we are gonna convert them into another domain. Can be Z domain, can be S domain, can be frequency domain. So in summary, we're gonna deal or consider only the signal with one independent variable and mainly the function of time. So that's why we split this signal in terms of time into two parts, as I mentioned. The first one is continuous time signal. As an example is the x of t, and t is a real numbering in this case. It can be from minus infinity to infinity. Discrete time signal, x of n, this is the notation that we're going to use. And in this case, n is an integer, is not a real number. So an example for continuous time signal can be x of t is equal to exponential to the minus t, and an example for the discrete time signal can be x of n is equal to 1/2 power of n. Okay, so we're gonna go over this classification next week in details. I'm just giving you some introduction about this course. Okay, let's give more visual example for the continuous versus discrete time signals. Assume that in your mobile device you're recording a speech signal, your voice, like at 32 millisecond in this case, as you see. And then we discretize this signal by using the ADC. So we represent this signal in terms of 256 samples. So we discretize this in time, as you see, over the x-axis. So this is a continuous time signal, and this is a discrete time signals for your voice signal. So we can categorize the signal types by the areas that is being used, like audio signals, control signals for the automotive and robots, graphics and imaging signals for entertainment or the medical, some medical signals that you use when you go to the hospital, to the doctor, for instance, like your, heart rate or MR, this kind of signals that we are talking about. Some communication signals that we use every day, like in Wi-Fi signal, GPS signal, or kind of 4G, 3G LTE, or 5G signals. Some instrumentation signals and military signals for the radar or for the warplanes, tanks and so on. Some telecom signals that we use for the fiber signals, or Ethernet signals, some network signals. And you can extend this list as well. So there are many types of signals depending on the area that is used. Okay, any question about signals so far? Okay, I guess it's clear. So we're gonna learn the details next week. Okay, the second question, what is the system? Any idea?
Can you repeat the question, please?
What is system? How do you define the system? So can you tell me a system?
It's a group of functions that take an input and provide you with a desirable output.
Yeah, kind of. It can be just one function. It doesn't have to be multiple function. But as you said, there's an input, there's an output. Right? Okay, so as your friend mentioned, that you have a system that is aimed to perform for a specific function, okay? And this system can be a mobile device, this system can be a robot, can be an drones, or it can be a computer, or it can be a camera, and so on, from simple to the very complex systems. But it has some input that process this input, and it gives you a desirable output. So it transforms input signals to the desirable output signals, basically. similar to the signals, we also classify the system into two parts. The first one is the continuous time system, but the second one is the discrete time systems. As you see here, this is a continuous time system because it has a system function of h. It has an input of u of t and output of y of t. If the signals, that is the input signal and the output signals, are continuous, we call this such system as a continuous time system. If the input as well as the output are discrete time signals, then this system is called discrete time system. Of course, we have some hybrid kind of system that is out of scope of this course. So we're going to simply consider two type of system. The first one is the continuous time system. The second one is the discrete time system. Okay, examples of systems is various. So, you know, you can come up hundreds of thousands of different systems that we use in our daily life, right? In robotics, in kind of radar, in, you know, kind of computers, in MR, in automotive infotainment or entertainment systems, in satellite, in, you know, mobile devices, tablets, smartphones, and in the automotive, so in like Siri, this kind of stuff, you know, drones, and mobile hologram, you know, digital twin, all this technology are, each of them is a system. Of course, very complicated system, which has many subsystems. So when we design such complex system, we first come up with the design, and basically it consists of multiple subsystems. So you have to analyze all these subsystems and put them together to analyze the whole systems. So these are very complex and final products that we can call. We have some more simple kind of systems. It can be a circuit, you know, or amplifier, just amplify your voltage input and current output. Or it can be just a single motor with the current input and torque as an output. It can be a simple kind of system that is a noise cancellation or removal audio filter. Or it can be you can come up with a system that just predict the stock price for a company. For instance, it like an artificial intelligence system that you provide the past stock history as an input, and it provide you the predicted future stock price as an output. And in digital image processing, you can provide a raw image as an input, and it can process this image as an output using kind of edge detection algorithm. So many hundreds of thousands of different systems that we can come up. So when we design these kind of systems, from simple to the complex systems, we follow some of the principles, some steps that we're going to learn in this course. So simply, this course will cover the mathematical description of signals and system and how they interact with each other, how do we analyze, and then how do we split into the small pieces or small subsystems, and then we combine them to make a very complex, advanced and extensive systems. Like some example to give you some idea about the analysis. You guys, I don't know, you guys remember CD? I think we are not longer using this kind of stuff, but in the past it was very popular. Now you guys are using cloud or kind of USB driver, right? And this kind of stuff. But in the past, we used a lot this standard music CD, compact disc, and this disc has some calculation based on the capacity and so on. For instance, for the music, we use a sampling rate of 44.1 kilohertz, and each sample is represented by 16 bits. And if you are gonna save as a 2-channel stereo, so the data transfer rate that is required is equal to 2-channel times 16-bit times the sampling frequency. You end up with the 1.4 megabit per second. So in order to transfer this music with such quality, you need to have such data transfer rate, which is 1.4 megabit per second. So if you're gonna transfer or store 1 hour of such music, you need 1 point times 3600, which is gonna end up with this 635 megabyte. I don't know if you guys remember that this such CD has a in the past was 700 megabyte capacity. So this 700 megabyte capacity comes with this calculation, basically. So you're gonna learn this kind of stuff, how to analyze and design a system. Or cell phone or mobile phone that you use, smartphone, it has many subsystems. It's a complex system, but it consists of many subsystems. For instance, the first one is the antenna that you collect or transmit your signal over the air. And then you pass this to the RF receiver subsystem, which is gonna process and down convert this to the baseband level, we call it. So we have some RF codec that down convert this to the baseband, 0 hertz. And once we are in the baseband, this is passed to the DSP chip, another subsystem that is going to process, demodulate, decode based on the instruction that you get from the microprocessor chip or other peripherals. And then after all this digital signal processing, the outcome is going to be the voice codec, for instance, to decode the voice and give this to your speaker. As you see, it consists of many subsystems, but you need to, come up with an analysis and design to come up with such a complex system. Another one is the VoIP, voice over IP. I'm sure most of you guys are using, which is used by many social media and voice chat program. So
what we do now isn't VoIP?
Yes. So we transfer the voice over the IP protocol over the internet. In these teams, in WhatsApp, in BIP, in Telegram, this kind of voice chat program. So they use this technology, which consists of many subsystems, as you see. Another one, in the past, we used a lot of portable media devices. This kind of stuff was, devices were separate and were selling like a DVD player or CD player, or in the cars, we put this as an entertainment system. As you see, it has a LCD panel, touch screen, and some stereo audio codec, video codec, video decoder, encoder, some CPU and DSP microprocessor, battery management, buffers and memories, some, other sensors, microphone, speaker, and so on. As you see, it's very complicated. In the past, this kind of device were separate, but nowadays all these devices are embedded into the chip, like in smartphone or mobile devices. But regardless of the system that you deal, so you need to follow up whoever the company it is. So they need to follow this signals and system design methodology to design such product or such systems that you are going to learn in this course. All right, so that's the introduction about to give some idea about the scope of this class. Any question? I guess it's clear.
Yep, crystal clear.
All right, so as I mentioned, so tomorrow we don't have this 1 hour. Next week, we're going to start our second lecture, which is going to be signals and systems. All right. Thank you for attendance. So I'll see you next week.
All right. Have a good week, sir.
Have a nice day.
Bye.